All right, let's get started. Okay, so this is where we left off in the memory diagram last time. So let's pick up here and finish this thing up. Why is my mic so much different right now? Look at that. Guy comes in and tests the mics, and he messes up all my volume. It's not being helpful. So this is where we left off last time. And let's kind of recap how we got here, and then we'll go on to this next line where we're creating the party class. We're creating an object of type party. So most of what we're looking at in this is how references move around our code and how we use references and how references are stored in the keyword this. That's a lot of what we're doing here. One thing that we saw last time is that once we lose a reference to an object, this object here, we no longer have any references to this object in memory. We don't have access to this object anymore. So it's a candidate for garbage collection. It may or may not be in memory. Java at its leisure can clean this up whenever it wants. But to us, it's gone. So in our memory diagrams, we cross it out to say we no longer have access to that object. It's gone to us. It doesn't exist anymore to us, and it'll eventually be garbage collected and literally not exist anymore. So we cross those out in our memory diagrams. Whenever we call a method, like we called hero.winBattle, hero stores the reference 320. Dot means follow the reference to the object to which it refers, and then we call winBattle from this object. When we call winBattle, we do two things. One, to figure out which winBattle method we're calling, we look at the type of the object that's calling it. This is an object of type character, so we're going to go to the winBattle method in the character class. And two, the object that called it, whatever reference that object has, this in the stack frame that's created is going to be a reference to the calling object. So winBattle called through the character at 320 is going to get that reference 320 as this. So any questions on how we got to this point before we crack open this player class? No questions? Do you accept donos on Twitch? No. I haven't even streamed on Twitch in a while. All right, let's move on. If there are no questions, let's move on to the party class. So we got a lot going on in one line. So let's go through what creating the party class is like. So when we create the party class, we're going to call its constructor new party, which as we've seen before, that's going to create an object on the heap. We're going to make up a reference number for it. We're going to create its instance variables, which are members and battles1, initialize battles1 to 0, and then put the constructor call on the stack with a reference to that object that's being created, and then call the code of the constructor. This code is going to update the members variable, this dot members. So we're talking about this variable right here. And we're going to set it equal to a new array list. So we're going to create a new array list. Whenever we see the keyword new, we know we're creating a new object on the heap. So we get a new array list on the heap. We're going to make up a reference number for it. And the constructor returns that reference, and it's stored in that members variable. So we called one constructor in our code. We just said new party, but the party constructor called another constructor and created another object on the heap. So we got two objects here through one constructor call that called another constructor. So this, and then we called it composition. Last time we talked about this for a big fancy word for it. But it just means that variables can have any type, when you create a class, you get a new type. And instance variables, they're variables just like any other variable. They can also have those types that are references to other objects. So we have an instance variable that stores a reference to another object on the heap. So we have an object that refers to another object, which is a perfectly valid thing to do. Now note when we call the ArrayList constructor, this does technically create a new stack frame. Creates a stack frame, puts it on the stack, calls the constructor, runs through the code in the ArrayList constructor, and does all that stuff, but we don't put it in our memory diagrams. So whenever we have code that's internal to Java, that comes with Java in the Java standard library, we don't trace through that code. We only trace through the code that we actually have access to, so that we actually care about. So in this example, only the code that we see, that's what we're going to trace. And more applicably, when you have a quiz, you're only tracing the code that you're given. The code that you can see, that's what you're tracing. And when that code calls internal Java methods, math.absoluteValue, new ArrayList, new hash map, anything that's internal to Java, you just skip over that. You just assume that entire line does its thing and returns, like in this case, a new ArrayList. You just assume that it resolves to a reference to a new ArrayList on the heap. You don't have to go through, draw the stack frame, do this and the reference. We don't do any of that if it's code that's internal to Java. Same when we're going to call add on that ArrayList. Since the add method is internal to Java, yeah, it technically does create a stack frame. We're just not we're not concerned with it in our memory diagrams. We're just going to assume it does what it says it does, and then move on with our code. And then we're going to get to these add character lines, and we're going to see more of the dot operator. So we've seen the dot operator. We're not seeing anything new here necessarily, not conceptually new, but we're going to start chaining together these dot operators, these dot calls. So when we have dot, it means this is a reference, and we want to follow the reference, the instructions, to go find the object to which it refers. And we can do that multiple times. So this dot members in this stack frame, we called add character through party dot add character. So this is the calling object. Party, look in the party class for a method named add character. This is a reference to the calling object, which is 746, and we're passing it a reference also. So we pass it a reference as a parameter. This is the first time or as an argument. This is the first time we've seen parameter that's a reference in a memory diagram. So member gets hero. Hero refers to 320, so member is 320. And then when we get to the method call itself, it's this dot members dot add. So we're just following two references. We follow one reference to get to another reference, follow that reference, and we just bounce around in the heap. Now notice that this array list, we don't have a reference to this array list on the stack. There's no reference to this thing on the stack. We only have a reference to it on the heap. So if we want to access this array list, we have to go through this object of type party to access it. We can't access it anywhere from over here from any stack frames. We can't do it. In fact, there's no way to do it. Since it's private and we don't have a getter for that, we're completely encapsulating this array list within the party object. We can't access it from the outside world except through add character and win battle is the only way we can access it. So this dot members dot add of member, so this resolves to this reference, and then we're calling the add method here of member. We go back to the stack frame. Whenever we have a new expression, we're going back to the stack frame. This is an entire expression, so it's in the stack frame. Member resolves to 320, and that's what we give the add method. When we call add on an array list, we get that value added to the next available index. In this case, it's an empty array list. The next available index is 0, so we get 320 added at index 0 in this array list. So there's a lot going on here, especially the next thing that we're going to see when we get to this beast of a line. But I'll argue that it's all stuff that we've seen, we're just throwing it all in one example and getting a lot of the, things into one line. If you've been tracking and understood everything we've been talking about up to this point, I think you'll be fine understanding what we're about to talk about. But if you're not good on everything up to now, I want your questions so I can get you there. So any questions on what just happened there? We're following multiple references. Which I think, as long as you understand references, gets kind of easy-ish once you honestly kind of turn your brain off and just blindly read the code the way the computer is going to read the code. What's this in the current stack frame? The current stack frame is the one that's lowest on our diagram that isn't crossed out. This is this reference here. Dot means actually go to the object being referred to. And then what are we doing? Members. Okay, I'm here right now. I'm at this object, and I'm looking for something called members. Oh, there it is. Members.add. So again, dot means I'm at a reference, and I'm looking for the object that's being referred to. That means jump over here, dot, and then I'm calling the add method right here. Okay, I'm calling add. I'm right here at this point, so I'm calling add on this array list. And what's the argument? Members. We go back to the stack frame. We always start at the stack frame when we're resolving an expression. And members is 320. So we're calling add right here and adding 320. Cool. We got 320 in that array list. We executed that line of code. So if you just kind of blindly go step by step, if you try to lump some of those steps together and say, you know what, I know what this line's doing, let me just jump over to this array list, then it's easy to make mistakes. But if you just blindly follow and parse the lines one portion at a time, it gets to be, in my opinion, a little straightforward. If you disagree, give me your questions. Let's hear them. If there are none, I'll just assume you all get it. This isn't the easiest topic to understand, but we have been talking about it for a week. So I think I would assume most of y'all are getting there. A week and a day, really. We started this last Monday with array list and hash map talking about references. When we call add character again, add character, party dot add character. So party dot add character, we call it from party. This is of type party, so we look in the party class for a method named add character. Add character of fighter is 555, so the calling object is this, and then fighter was the argument, so member here gets the value 555, and then we go this dot members dot add 555, and we get 555 in the next available index, which is index 1. We get to the next method call. It starts off similar enough. Party dot win battle. So here's where it becomes important what the type is. When we call a method, what method is called depends on the type of the object. We have two methods called win battle. So for add character, we didn't have to think about it much. We just found the method called add character. Now there's two win battle methods. So the method that's called depends on the type of the calling object. So we look at this dot win battle. We look at the type of the object where we're at when this method call occurs. It's party, so we're going to look in the party class for a method named win battle. And when we put that win battle frame on the stack, this is going to be a reference to the calling object, 746 in this case. The argument is 20. So 20 is assigned the parameter xp, so we get xp of 20. We increment this dot battles 1, this dot battles 1, increment that by 1. We hit a loop, so we have our dashed box for our code block. The iteration variable is declared inside the block of the loop. So we get x equals 0 inside the loop. We're going to check our condition, x less than this dot members dot Size, so we're calling size on this array list. It's going to return 2. 0 is less than 2, so we're going to execute the body of the loop, and we arrive at this beast of a line. So any questions on how we got here at all? How we got to this line? Highlight it. How we got to this line before we start parsing through everything that's going on here. And if you can understand this line and all the madness that's going on here, then you got a good lock on references. References and how references are stored in this, how references are passed across stack frames with this, and as just parameters being references. Any questions on any of that before I get into this line? There's a lot of moving pieces with this line. We see 3 dot operators, a method call that takes a reference. Actually, no, we don't have a method call that takes a reference. But a lot of dot operators. If not, let's jump into it. All right, let's do this line. So again, I maintain that this isn't any more complicated than what we've already seen. We're just taking everything and mashing it together in one line. So it is complicated in the way that we're combining things, but there's no new concept here. If you understand the concept that we did so far, you're good here. If you don't understand that concept, I want to know about it so I can explain it. Give me another shot. Let me try to explain it better if it's not making sense. Okay, this .members.get of x .win battle of xp. Whoo, baby. So I think my expectation, I should say, is that you could understand what this line does even before 116 in your 115 days. You could go through this maybe without the classes stuff. You could understand a line like this and figure out what it does. By all the context clues and everything, we're calling win battle on a party. The party has 2 characters in it, so we're probably going to call win battle on each of those characters, so each character can get the XP for the battle, and they can update their number of battles one by one. I would think you would be able to do that. Maybe I'm wrong, maybe not. But you wouldn't be able to explain how it gets its job done. You would not be able to trace through the code, especially in 115, or even maybe right now. So that's what we want to talk about today. How does it actually get that done? How does it actually distribute XP across the characters in the party? And for what it's worth, all characters get full XP. We're not dividing the XP across all party members. So let's go through it, and we're just going to go one piece at a time and parse through everything that's going on here. So first we need to resolve this expression. I just said one piece at a time, so let me do one at a time. This, in the current stack frame, we always start at the active stack frame. This dot means follow the reference, so we're at the party, this party at 746. Dot members, so we're at this reference, where we have this reference in our grasp. We're going to say dot, which means follow the reference to the object being referred to. Dot get, and we're going to call the get method at this array list. This array list is going to call get, and our argument is x. We have another expression to evaluate, so we start back at the stack frame again. We go to the stack frame and check what x is. X is 0, so we're going to get the value at index 0, which is OX320. So this entire expression with this method call of .get of x resolves to the reference 320. Now with that reference, we're going to call win battle. So we're going to take that reference 320 and say dot win battle and call the win battle method with this character as the calling object. So we call win battle, we pass XP, which again, another expression we have to evaluate. Start in the stack frame, we find XP right away. XP is 20, so we're going to call win battle from this character at OX320 with an argument of 20. So we jumped all around memory. We jumped from the party to the array list to a character, but we're just following references. Every time we see dot, we're following a reference to an object. And then we add that stack frame to the call, this 320. The type of the object was character, so we're looking in the character class for a win battle method. XP was 20. XP resolved to 20. XP gets the value 20. And then we call win battle a new stack frame with this of 320, XP of 20. And then we run the 2 lines of code in this method. This dot battles 1 increment. This dot XP. So this dot battles 1, bump it up by 1. This dot XP, bump it up by 20. And the method ends. Well, a few things to note, but one thing I want to add to this. Whenever we're creating a new stack frame, especially when it's called from within another stack frame like this, we never put a stack frame inside of another stack frame. Whenever we create a new stack frame, we have a method call from a stack frame. It goes, and we saw this for in the last example, not in this example yet, but I didn't mention it in the last one. I wanted to save it for now. But whenever we call a method from inside a method, the new stack frame goes on top of the stack. It does not go inside the stack frame from which it was called. This is not just for our memory diagram's sake. This is how the computer works. Each stack frame is a separate, isolated portion of the stack, and this literally is a stack of stack frames. It's not stack frames inside stack frames inside stack frames. It's a stack of stack frames. So we put that new stack frame in a new section of the stack that's completely isolated from the previous stack frame. They're completely isolated environments. When a stack frame is active, the variables within that stack frame are the only variables that can be accessed. We can't jump across stack frames. The stack frames are not contained within each other. Code blocks are contained within a stack frame. So code blocks we do draw inside them. It's, again, not for our memory diagrams. That's actually how computers work. When the computer's running our code, stack frames are separate things. Code blocks are inside stack frames. So don't draw your stack frames inside stack frames. It's an easy thing to grade. Once we see a stack frame in a stack frame, it's a big X through the whole thing. And sorry, try again. No stack frames within stack frames. It's not how computers work. It's not how we're going to draw them on our memory diagrams. We're going to draw them the way that they do go. And then when the stack frame ends, it'll give control back to whatever stack frame is on the top of the stack, which will go back to this stack frame. And we do it again. I won't belabor the loop, but we'll increment x. Check the condition. Condition's still true, so we run it again. This dot members dot get of 1 gives us 555 dot win battle. So we call win battle on this character with 20 XP. They mark that they won a battle through this dot battles 1, and then they gain that XP. This dot XP plus equals 20 because it's 20 in this stack frame. When we call win battle, it's called through a character, so we use this win battle, and that character is at OX555, the calling object. That's what's stored in this. XP is 20, because right here, win battle of 20 was called from this stack frame, where XP resolved to 20. So in this stack frame, XP got the value 20. That stack frame returns. We get control back here. X increments to 2. We get 2 less than this dot members dot size. This dot members dot size is 2. So 2 less than 2 is false. So we never execute the loop with x equals 2. The loop ends. I'm going to gray it out on my slides. You would cross it out on your memory diagrams. Unless you want, if you want to shade in with a pencil and shade in your memory diagrams like this, go ahead. But you would, if you're not doing that, put an X through this. It's not in memory anymore. And then we hit the end of the stack frame. That's not in memory anymore. And we hit the end of the program. There's got to be more questions than y'all are giving me. I keep looking at my phone. I keep seeing the Twitch question. Hoping it's something new and it's always the same one. Which I guess I'll answer in more detail. Once you accept a Twitch, I forget what it is. It's partners like the higher one. I forget what the first one is. But once you accept that you'll have revenue on your stream and people can donate bits and subscribe, once you do that, they start showing ads on your stream. You'll get pre-roll ads, and I'm not going to expose you all to ads, especially when I use it for lectures. It just doesn't sit well. There's 2 win battle methods. Can you explain that? Yes. So in the code, win battle is only called once here. So we called win battle here. That's this stack frame. This is the party's win battle. And we only call win battle once here, but it's inside a loop that executes twice. So we're looping over all the values in the array list. So we hit this line of code twice. So we call win battle, the first iteration of the loop. And when we loop around again with x equals 1, we're going to call win battle again with x equals 1 with the second element in the array list. So we do get 2 stack frames. We actually get 3 win battles. The party's win battle, the first character's win battle at 320, and the second character's win battle at 555. So we do get 3 calls on the stack of win battle methods, 2 different methods, and one of those 2 different times called with a different value for this. It was called with the same argument. Notice XP is the same in both of these. They have much, much different behavior because there are 2 different references for the calling object. 2 different objects called these 2 different methods, the same method twice. So we got different values for this, so they did have different effects on the memory of our program. And also notice that every method in this program returns void. Everything we called returns void. The only exception are the constructor calls, which return references to the object that was created. Yet we had a lot of change that happened to our program throughout the course of its run. So we have methods that return void, but we're calling them for their side effects because they change the state of objects on the heap. So we called win battle twice. Both times it returned void, but each time it modified the object, the calling object, through this. So the first time it modified this object, the second time it modified this object. Yeah, I mean, maybe. Or cash. Or maybe I'll Patreon someday. There wouldn't be any ads. Yeah.
If there are 2 method calls from 2 different classes with the same name, in the memory diagram, should we identify which class is part of it?
No. It's a good question. It's something we could do. Maybe someday we'll add them to memory diagrams, but right now we're not. So the question is, we have 2 different methods defined in 2 different classes. We have the party's win battle and the character's win battle. So why not denote these as what actual method is being called, like party.winBattle and character.winBattle? We don't. Maybe someday we'll add that. It would make things a little more clear. The defense of why we don't do that is because you can look at this, look at what type is, and then we can verify that way if you know what you're talking about on your memory diagrams. So if this is a reference to the right type, then we know that's the method that you're calling. So we use that for grading, but to be more explicit and just more clear about things, maybe someday. I don't want to because character.winBattle doesn't fit on a slide as well, just logistical reasons. But
I'm also thinking of writing it below the method itself.
Like win battle, new line, party, character?
Yeah, something like that.
We might do that. Maybe that's what we'll do in the future. For this semester, we're not doing it. But yeah, maybe future semesters, that's what we'll do. Maybe. I don't know. Paul and I will have to talk about that a bit and maybe get feedback from a lot of people, a lot of students, and see what makes the most sense. Any other questions? Why there are 2... Oh, that question was why there are 2 win battle methods, not method calls. I read that as method calls. There are 2 win battle methods because we wanted two methods with the same name in different classes, just so we can make that point of when we call win battle, which one is called. There's a win battle here and a win battle here. They both return void. They both take an int named XP. They look like the same methods. The difference is they're defined in two different classes. So if win method is called, every method is called from an object unless it's a static method, but we're pretty much done with static methods now. That was just a crutch that we used for the first 2 weeks because we didn't know what classes were yet. When we call a method, it's going to be called through an object. That object is going to have a type, and we're going to look at that type for the method to be called. So we call a method through this object of type character, we mean the character win battle. When we call win battle through this object of type party, we mean the party's win battle. So it depends on the type of the calling object for which method we're going to get when we call the method. But we purposely named it the same thing in both classes just to make that point. That will, in 3 weeks, that'll come back in a big way. So we want to warm you up to that idea right now. Because right now it seems like, well, just name them different things, dummy. In 3 weeks, we won't have that option when we talk about something called inheritance. So we're kind of building up to that. We're foreshadowing that a bit. Yeah. I was having a little trouble here, and I think you said, so we have two new characters in the main method, right? You're talking about these lines? Yeah. So why are we doing it, or what is this code doing? So the why is just for a lecture example. This isn't something you would actually do. You would not have this line at all. You would just say hero equals new character, and then that hero would be that character. The reason we have it set up is just to show garbage collection for the lecture example, but you wouldn't actually do this in real code. So for the lecture example, I just want to show hero being reassigned to another new character, so that this character which was created, which is this one here, ends up getting garbage collected because we no longer have a reference to that object. But realistically, why would we create an object to immediately have it be garbage collected? We wouldn't actually do that. We will see garbage collection. It does make sense in a lot of contexts. But in this context where line 1 we create it and line 2 we get rid of it, it doesn't really make sense. Just for a lecture example. Just so I can cross this out and say, this is what garbage collection is. Is that good? Cool. All right. Be done with those slides then. So that's my last slide, which means the rest of the day we're hanging out in IntelliJ. We're going to see some live coding. Paul does live coding in every class. I like getting to some live coding, but it's I don't find as much time to fit it in. He explains the concepts while he's live coding. If that works for you, go check out his videos on Panopto. But I want to jump back to this player class and kind of refresh what we've seen with this player class. We're moving away from the character and party and back to player. This player had HP, max HP, attack power, name. We didn't really see attack power, and I won't use it today just because we haven't really talked about it. I just briefly mentioned it in one slide, so I don't expect you to get the attack power stuff. We had a constructor that takes name and max HP, sets the instance variables to what they should be, setting HP to its max HP. We have our getters and setters. The set HP made sure that we couldn't set our HP above our max HP. If somebody tries, it's just going to top off their health. Getters and setters, a two-string, and then some take damage and attack. Again, I didn't really talk about this stuff, so I'm not going to mention it today. Not going to do that today. The question that I have that we want to talk about is how do we test a class? How do we test a class? We wrote a player class, and we want to test it. So the practical answer for your current task 2, is in test classes, the testing code's given to you. once you start writing your test 2 code, you'll comment this stuff in. I'm going to get all kinds of errors here because I didn't write my song class yet. But once you write your song class, you write the methods that you need, then you comment this out, get the test, run the test, and see if it passes. So for your homework, you can use these tests because we didn't really talk about testing classes, so we just gave you the test so you have an example to go by. And then later in the course, when we do ask you to test your classes, you can use this as a reference, use the lecture as a reference, and then know how to test your own classes. But I want to talk a little bit about how we actually do that. So to test a class, we first need an object of that type. We need to instantiate the class to get an object of that type. So we're going to say player, I'm just going to call it P1, equals new player. And I'm going to stick with what we did in the repo so far. Goku and a health of, we'll say 500 this time. So I'm going to create a new object with a name of Goku and HP, a max HP of 500. So at this point, I would expect max HP to be 500, HP to be 500, and name to be Goku. So now that we created an object, we can test the object. We can't test the class directly. Create instances of that class and test those objects. So I want to do assert true. Oh, come on. Assert true. P1.get, start with max HP, equals 500. So we're going to assert that the max HP is 500. Paul got mad at me because I had some examples without hint text, so I'll add hint text to all my examples today, just to make him happy, even though it won't help. He'll still be mad about something I do. So I'm going to do P1.get max HP, which is going to give me an error. So the error is this method expects a string, but I'm giving it an int. I can show you, but I just ran into this in the last lecture, so I know what it's going to say. Required type string provided int. I gave it an int. It expected a string. I would hope that this method would just call toString, but it's a primitive, so it can't do that. I thought it would just do some type checking and convert it to a string, but it doesn't. Like the print line method will do all that. It'll convert this to a string. This method doesn't. So we have to do a little bit of work. We can do string.value of, and that converts it to a string. I don't know about you, but I don't really like that. So I'm just going to add some text here. When you concatenate a string with an int, this operator will convert the int to a string and then concatenate the values. This is why this hasn't come up before. So if I just say got, I don't feel like writing lengthy strings while I'm live coding, but this is where we would say, I was expecting this, but I got this, something like that. I'm just going to say this is what I got, and then I can look at the code to figure out what actually happened. So if I run this, I'm going to check if the max HP is 500. I expect it to be 500. And when you're doing checks like this, you should hard code the values. You can store these in variables if you want, like int expected 500, which is what I do when I'm not watching the clock and trying to get things done by lecture. I'll store everything in variables so we don't have what's called magic numbers in our code. But you do want the hard-coded expected value. Don't write code that's going to compute what you expect. It asks for mistakes like what I see sometimes, p1.getMaxHP equal p1.getMaxHP. Sometimes students will write code like that, and they're not actually testing anything. Hard code the values that you expect to the best of your ability. When we get to the later programming tasks in the course, sometimes you will have to have a little bit of code doing a little bit of logic for your expected values. But for now, you should be able to hard code everything. I expect 500. I'm going to put that right in my code, typing out 500 and expecting that I get 500. And we want to just check everything. So I should also get HP should be 500. Get name And remember, we never use equal equal to compare our strings. Even IntelliJ is like, hey, you really shouldn't do that. What are you doing? There's really no reason to use equal equal for strings, even when your IDE is telling you we'll use equals. Your IDE literally highlights it and says don't do that. Of course, sometimes it highlights things and we ignore it. It doesn't want us to use assert true. It wants us to use assert equals. If you use assert equals, go for it. That will actually call dot equals on your strings in this example. I'm just going to use assert true in lecture because I want to show how you actually do the comparisons instead of having the library do them for us. So we want to make sure the name is what we expect. And then when you're testing your code, in general, but inside this class for a homework assignment, you'll look at the programming task, look at the write-up, and anything that you coded that was part of that write-up, test it. So we would want quite a few tests. I won't go through everything in this example, but I would do p1.setName, Gohan, and I want to make sure that when I ask p1 for its name, that's going to be Gohan after that method call. Same thing with, let me grab this one. Same thing with set HP. If Goku's hurt, we'll put him all the way down to 1 health. Get HP. That should be accurate. That should work. Oh my goodness, come on. And then if I set health to, let's say, 1,000,000, here we don't expect 1,000,000. We expect our checks to kick in and have it say, hey, you can't do over 1,000,000. Let me make sure I know what we set it to. And that should just top them off at full health. If we run this code, I would expect all these tests to pass. And like I always say, you've heard me say this once. I'm like, I say this all the time. Say we don't do that, we don't have this check. So I always like to see my test pass is the thing I always say. I always like to pass. I always like to see my test fail. So I want to see my test fail. So I'm going to intentionally break my code and run my test again just to make sure the test fails, to make sure that the test is actually testing something. Just to make sure, if I actually type p1.getHP equal p1.getHP, which I've made that mistake in the past, it happens, that you aren't doing things like that. I got assertion error, I get by hint text, and click on the exact line that failed. So when I ran this line and I expected 500, I got 1,000,000, and I can look at what happened here. Okay, I set it to 1,000,000, and clearly something's going wrong with my max HP check, and then I can go to my code and fix that. And of course, I'm going to see that the whole thing's broken. We could do something similar to set name. Actually, I didn't try this, if this gives an error. Okay, so this is a mistake someone might make. Probably at least one of you is going to make this mistake on the homework. Name equals name. I run this. In some languages, you get a straight-up error doing that, namely Scala. It wouldn't even let you do this. But it's not going to do this. The return value was null. That's a big, scary, complex error to get. What this is doing, I thought it would initialize to empty string, actually. We never initialized set name, or we never initialized name, so we got the default value. I thought it would be empty string first string, but as with other objects, I guess it is initializing to null. So we don't have any value stored in name. And we get an assertion error. So that's bad. The reason for this is that name, whenever you have a variable name like this, it's going to look in the stack frame, and it's going to find the parameter name, and then that's it. Okay, parameter name equals name. Name is the parameter. We're setting the parameter equal to itself. Okay, Java will do that. If we name this something else, and we can see this change purple, if we name it something else, then we don't find a variable named name in the stack frame. So Java's going to look at the reference referred to by this, head over to that object in the heap, and then look for a variable named name, an instance variable named name. Then we run this and we'll get the correct behavior that we want because we rename this to something else that doesn't collide with a name inside the object. Or you do what I like to do, be explicit so you never make this mistake. This dot makes it very clear. Hey, Java, I don't care what you want to do. I want to head over to this object in the heap. And there's no question about what's going on. This is just going to work, no matter, even if I use the same variable name. Okay. Let's create another test. Let's create another test. I'm going to test some references. And I want to create another player, P2. And I want to check if these things are equal. These two players are equal. So let's assert true. P1 equal P2, right? Just to make Paul happy, I'll put some string here. And I'm going to check if those two values are equal. Now, what do I expect to happen here? Now, we haven't talked about this explicitly yet, but just based on your understanding, can you deduce what's going to be checked and what's going to happen with this test? Where can you find the memory diagram from lab if I want to make a copy? I don't think that was distributed electronically. I think you have to go to lab and take pictures or write it down. The idea is that as the TAs are going through the memory diagram, you're also taking notes and going through it. It'll fail because it's looking at the references, exactly. Is that what you're going to say? Cool. So when we say equal, what we're checking, what Java's checking, are the values stored in these variables. The values stored at P1 and the values stored at P2 are references to objects on the heap. We have two different objects on the heap. P1 and P2 store different references. So this test is going to fail because it's checking if the values stored in the variables are the same. It's not going to follow the references and check the objects at all. It's just checking the references. So if we want to check these two objects, we're going to have to add some extra logic here. Well, one, we could write an equals method, but we haven't done that yet in this class. So what we'll do is access each variable. Let's do getName.equals. Always use .equals for your strings. P2.getName. And that should pass. We're going to check the actual values of the objects, not the values of the variables storing the references to those objects.